All right, so functions. Functions are actually just algebra equations, but we put some fancy names to some things to understand what the different parts mean. So any algebra equation we can call a relation based on the words where the word relationship comes from. But there's a relationship when we have an equation between the input values, x, and the output values, y. So like with the example that I have down up here, if given the equation y equals 2x, that would be my relation. If we input x equals 3, in other words, if we substitute 3 in for x, the result, my output, would be 6. And typically when we start talking about input and output values, we typically will write those as a coordinate point. So we'll write our input, our x first, and then our output, our y, second. So if somebody comes along, they can say, ooh, I plugged in a 3 and I got out a 6. Okay. So again, it's just a little bit of a change in language. So when we start looking at the definitions of these things to make sure we're all speaking the same language, okay, a relation is the relationship. If you think about relationships, you know, it's how two people get along. Well, here it's how a couple of values get along. So it's the relationship that my input and output have. You know, what happens when I plug in the x and get out a y? You know, are there more than one y value? You know, how's this work? But the two things that we tend to jump into the most when we're doing this are the next two words. So I'm going to star these up here. The domain is all of the x values in a relation. In other words, it's every possible x value for that particular equation that I could plug in. Now sometimes there's an infinite number, sometimes there's just a limited number, and we're going to take a peek at some of those here in just a bit. My range then is all of my y values in a relation. So when I plug those x values in, what do I get out? What are the answers that I get? What's the possibilities? And that's just another way we use the word range. And then the final part, which is actually the definition of our whole section, functions. When an equation is a function, when a relation is a function, there is exactly, no more, no less, one output for each input. In other words, there's exactly one y value that goes with each x. So if I plug in 2, I get out 5. I plug in 3, I get out 7. Every time I plug in an x, I get one y value out, not more, not less. You're like, there's actually ways I can get more or less? There are, and we're going to take a look at some of those here momentarily. But again, our biggest ones in here are these two, and then maybe function kind of a distant third, because we're going to look to see how we figure these things out based on the information that we get. All right, let me scooch up a bit here. So for example, identify the domain and range, then tell whether the relation's a function. Okay, so my domain here, input and x are the same thing. You know, I put that number in. That's the x value. And typically when we write these, we use what are called braces. Now braces, some of you will say it just looks like a squiggly line, and it does kind of, but if you want to kind of get something into your head, it's like a silhouette of a guy with a pointy nose and a really big forehead and chin is basically what we're looking at here. And then we just list the x values in order from least to greatest, because that's just how we do things in math. Would it be terribly wrong if I ended up putting them in a different order? No, but it's not really correct either. My range is my output values, my y values. And again, I really want to try and write these in order from least to greatest. What's that? You're right. Because I start looking and I go, okay, well, how do I tell if this is a function? Well, for each one x, there should be one y. Okay, -3, 3. Okay. 1, -2, and 1, 1. For this x value of 1, there's 2 outputs. There's 2 y values. That doesn't fly. So this particular one is not a function because I have 2 y values or 2 outputs for the same x value or the same input. And be prepared to, if you say it's not, to explain why it's not. Either saying x equals 1 goes with these 2 y's, or literally to write it out this way. I want you to be able to explain to me why something is, and not just, I don't know, I'll guess one or the other and hope I'm right. But that's how we check on these. So 1x, 1y, not 1x, 2 y's. It doesn't work. And then for this next one, again, my input is my x values. Now, if sometime they write the same number in there more than once, I don't need to write it more than once, because the value would still be covered. And my range is my output values. But again, is it a function? Is it 1-to-1? For each x, is there only one y? X, 1y, x, 1y. And some of you are like, wait a minute though, it's the same y. Doesn't matter. As long as this x only has one y value, even if it matches a y value, it's okay. And 4 to -2, there's 1 for each. So yes, this one is a function. There is one y value for each x. So y double up's not bad. X double up, not happening. And when it comes to looking at it this way or in coordinate points, that's how you figure that part out. You just look to see, do I get that repeating x value? Now, are they always going to be in a chart form? Nope. Sometimes we're going to have graphs. Now, before we get to the function part, I want to talk a little bit about domain and range. Because again, domain is my x values. But it's not just individual points this time. They're connected, which means every single x value in here is included. Well, I don't want to write all those. Holy cow, that'd take forever. So instead, when I'm doing these, I'm going to work on my domain looking at my x values from the left to the right. So I need to find the farthest point to the left and then figure out what its x value is. And sometimes I'll even draw a line back up to the x-axis to help me. So we start at -6. And again, notice I'm not using a brace, I'm using a bracket because that point is included. So then I go, okay, where's the furthest point to the right? Right here. What's its x value? +6. So I use interval notation when there's lines involved. Dots, I use the individual points, but lines, I got to do it this way. So then I move myself to range, and I go, okay, that's y. My y values from the bottom to the top of my graph. So the least to the greatest. So I find the lowest point, look at its y value, which would be -3. And then I look for the top value that I see with my y, which is up here, which is at 4. Then comes the part that's a little different. You're like, well, how do I tell if it's a function or not? We're going to use what's called the vertical line test. Now again, vertical lines go up and down. It's a function if no vertical line intersects the graph at more than one point. In other words, for every x is there only one y. And so I start to go through, and at any point, if I look, as long as I can only see one part of the graph through my vertical line, I'm okay. So I go through, yep, only see one part, one part, one part. And so as long as I can do that all the way through, it's a function. And we're going to see some that aren't, so you kind of have something to contrast to here in a minute, because usually the first couple are like, what? So just kind of stick with me here, and we can kind of compare and contrast here in a little bit. Second one, same thing. Okay, domain, leftmost x value, -7. Again, if you need to draw down to see, rightmost points at 6. Range, same thing. Bottom, -1 to top, 8. And again, I try running through with my vertical line test. Now again, the extra lines I drew in aren't part of my graph, just the black line. So again, I'm kind of looking, yeah, just there, just there, just there. So this one seems to work again, and we start to doubt if any of these are ever not going to be a function, just because everything that we've got so far. Now, when we flip over, though, the very first one we get into, ooh, things are getting different. Okay, I'm like, okay, domain's my x's, so this is farthest to the right. Here's farthest to the left. So you're like, but it's not on a whole number on the left. That's okay, just guesstimate to the best of your ability. So that looks like it's about -4.5. And over here to the right, it basically looks like it's on 7. Range works the same way. Bottom and top, putting dots on there isn't a bad idea if they're not on there. Looks like about -2 to +2. If you've got a little more specific, we're like 1.9 or something, that's okay. But the big thing on this one is it a function? And my best example is those 2 red dots that I see. When I go through here and I line up my vertical line, here's a single x value, but it has 2 y values. I see 2 dots at once. That's bad. So this is not a function, because there's 2 y's for 1 x value. So if I ever see 2 points at once during the vertical line test, that's just going to be no. So we look at it that way. Now, are there more twists? Absolutely. Okay, we're just going to work down the ones down the right side of the note sheet here. Then we're going to take a look at a couple of the homework problems. So here's something new on 4. Now I got arrows. What's that do? Well, the arrow just means that graph continues to go on and on and on and on off the paper, through the wall, and everything else. So when I'm trying to figure out what point's most left, you're like, well, I don't know, because it just keeps going and going. So if it keeps going and going to the left, we use -infinity because it has no end. And I use the parenthesis because there's not one specific point I can tell you it's going to be at, because it just keeps going. For the right, same thing. It goes and goes and goes forever. So typically when we see arrows, we're going to see lots of things with infinity, because it just goes and goes forever. Now my range, I see it goes up, 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 so I know that part. But where's the bottom y value of this graph? It's at 0, because it's right here. And if I go back to the y-axis, it starts at 0 and then goes up. And then I just, again, piece of paper, my finger, a pencil, whatever. I just kind of run through quick, checking a few places. 1 point, 1 point, 1 point. Yep, that's all. That's still good. But again, you've got to watch to see if there's arrows or points or what there are so this doesn't mess you up. Bless you. So then I get to 6. And I'm like, okay, there's an arrow there. Is there supposed to be one here? No. If you don't see an arrow, we can even replace it with a dot to make it a little more obvious for us. So my domain, my point furthest to the left, looking at it from an x point of view, looks at about 4.5, negative 4.5, excuse me. But then again, the arrow means this is going to keep going up and up and up and right and right and right. We see arrows, there's going to be some infinity involved. Range works the same way. It's going up forever, but here's my bottom point, and again, look at its y value of -3. And again, I don't see anything to tell me that this isn't going to be a function. Because again, I start working my vertical line through, double checking. Okay, that one looks okay. So you're like, shoot, is the oval the only time it's going to be not a function? Oh, let's see. Okay. Last one. Ooh. Arrows, so I know those keep going. So if it keeps going forever to the left, negative infinity. Here's where I seem to be the furthest to the right. So it's about 4. Again, if you use 3.5 or 3 point anything, that would be okay, because again, we're pretty close. And then range goes down forever, goes up forever. Not quite as obvious as some of the other ones, but it still does. But then the function question. I get here and I'm like, uh-oh, here and here the graph's going through. 2 points doesn't work. If that vertical line ever goes through 2 points of your graph, that's a big old no. Definitive no at that. So on the bottom of the sheet is the assignment. There's a couple problems there where your answers will be in interval notation, but for the most part, these are going to be solved. So here's what I want to do.
Is there a question?
Sure, I'm sorry.
711 right next to it, would it be a no because there's like a line that's almost completely straight at the right?
That is arguable. The argument somebody gave me earlier, and I agreed with, was it looks like this kind of starts to curve out and curve back, so there's going to be one small point somewhere where it would go through two. So yeah, I'd say that one's a no. I absolutely would. Sure. So here's what we'll do. I'll kind of pop this up here, and then I'll have you guys get some books too. So the couple I wanted to look at was 17, and then I'm going to look at 26 because it's real close to what 25 is. So I just want you to kind of get a feel for how these guys are going to work. So here's the actual question. I'll write it a little bigger in case some of you can't see it. And the directions are evaluate each function for the given value of x and write the input and output as an ordered pair. You're like, what's this f of x thing? F of x is a fancy way of saying y equals. Okay? These guys are one and the same. So then it says, okay, evaluate it. In other words, plug the 4 in for the x and find the answer. I can handle that. So let's see, 68 plus 3 is 71. That's my y, or my f of x, but I'm not quite set. Write the input, x, the number I plugged in, comma, the output, f of x, or y, as an ordered pair. That's what I want to get to at the end. The other stuff's important, but I've got to get that solution down in the way that it's being asked for. So when you're doing 17, 19, and 21, that's the format we're looking for. And that's a little different than some of the ones we did on the notes, so I wanted to make sure we had that. The other one is we get to apply something we used to do. Down here, and I know, you're like, we don't have to do 26. I know, but I'm not going to do the only one that's like this. That'd be kind of silly. Write a function rule. Ooh, we got to write the expression. To model the cost per month of a long-distance cell phone calling plan. Then evaluate the function for the given number of minutes. Okay. So this place, we have a monthly service fee, and then we pay a rate per minute. So, okay, so my cost would be the monthly fee plus the rate times the number of minutes I use. Okay, that would be my function, or my function rule. Then my job is to plug the minutes used number in for M and actually figure out what this would cost. So, now again, I'm not quite situated. Made my expression. I've evaluated it to find out the cost. Now again, I want the answer like we did in that first one. The number you plugged in is your input. So when we do an ordered pair, input goes first. Bless you. And then the output, whatever I get out for my final answer, goes as the second part of the coordinate point. Everything else on this goes along with what we did with looking at the graphs and figuring out domain and range and things like that. So you've got some examples for that, or there's actually problems in the book they always mention to the side here that you can always look at a page or two back if you need to.